computer. That should do it. Okay, folks, let me jump into this. All right. All right, ladies and gentlemen. I'm going to talk about, really, in some ways, this is, in my opinion, kind of the first real, true pre-algebra week where we're really actually getting into what is traditionally considered to be pre-algebra concepts. Of course, you need to learn about positive and negative numbers, integers, but you do that. And then traditionally, when I was taking these math courses, way back a couple of weeks ago, joking, this understanding how to simplify algebraic terms was a big part of pre-algebra. So I'm going to let you guys copy down what's on the screen. I'm going to freeze this for just a moment, and then I will come right back. Oops, what did I just do? That was bad. Sorry. Okay, we're back. All right. Zoom recording. Okay. So in kind of pre-algebra, we have something they call a term. Okay. And this idea of a term is something that it's like just X is a term by itself. 5 is considered a term. Okay. Some ways I'm comparing it to English. It's like a word. 5X is a term. Or 5 squared. If I had 5 squared like this, that's a term. Okay. So in mathematics, just kind of know that they sometimes they'll call them terms, and they, like, for instance, in this expression now, I like to refer to this as, like English, it's kind of like a phrase. There's a sentence and there's a phrase. A phrase is part of a sentence. An expression is like 5x plus 8. So this is like a polynomial. Contains one or more terms that are combined by addition or subtraction. So we have this as it's one of the types of polynomials. And I have 2 terms. I've got 5x, that's considered a term because they're combined, they're next to each other. And 8 is a term, okay? So this is 2 terms. This is a polynomial that has 2 terms. And so that's the basic idea, that a term could be by the way, a constant, I don't know if I have this, but you might want to write this down in your notes here. A constant, okay, equals any number. Basically, it's a number, okay? And here's why they call that a constant in algebra. Because like 3 or 1/2, or 8 or -2, those are all constants because they're constantly the same. And that's why they chose that name. They don't change. They're constant, like the Constitution or constellation. Okay, they're up there for permanently. And so, but think of them as a number because that's what they call a number. Okay, and then a variable, which I think we've talked about in this class for the last couple of weeks. A variable is a vowel. Okay, it's a letter, and they do change. Okay, like A can mean, or X or Y. They change depending on what number actually solves the equation. All right, speaking of equations, we have our last term on this slide here. An equation it looks like it's almost got the word equal in it, okay? So if you added this to your notes here to help you remember, when you see equation, what they're talking about is you've got 2 expressions that have an equal sign in the middle of them, okay? And so they call that an equation. When you have an equal sign, something equals something else. 5x plus 8 equals 48. This is called an equation. And that's just the term. So if you're wondering what I'm doing tonight right now for this first slide or so, I'm introducing you to some of the lingo, the vocabulary with which we speak about mathematics and especially algebra. okay? So you kind of know what we're talking about. All right, so I hope I gave you enough time kind of to get those basic ideas down. I'm going to move up to, these are the three most common types of polynomials, okay? And I'll give you a moment. I'm afraid to touch anything now on my screen. Pause. I hope my pacing is somewhat close. So of the polynomials, poly means many in like terms, okay? A mono, you've probably hopefully heard this before, mono means one, okay? And it's just a one-term polynomial. So 5x is considered, like we said on the last slide, one term, okay? And so, you know, if I ask you, identify the monomial on this page, you could look up and say, oh, it's this green one here. That's has one term in it. Bi, you know, like biennial, twice a year, means two. And just like it says, it's two terms, okay? So a polynomial that has something, a term, separated by plus or minus. That's really key that you hear that plus or minus. Um, separated by that, I have two terms there, so it's called a binomial. And then trie, you probably know, if you want to circle that, put a box around that in your notes, trie means three. And of course, it's three terms. And here we go. First term, second term, and they're all separated by plus or minus, okay? So that's what's called a trinomial, has three terms, all right? So just three different types. Those are the most common polynomials that you run into in algebra. Now, this slide, I don't want you to copy down anything. I just want you to look at it and go, okay, I'm absorbing this information that the teacher has here. So here are some examples of what we just showed you, okay? Mono, one, okay? And this is one term here. Minus 2b, this is considered one term, and here's why. Do you see how there's no plus or minus? They're multiplied by each other, 2 times b, okay? This is like, yeah, it's minus 2 times b in a sense. When they're right next to each other, that means multiply. I've got it twice here for some reason. Now this one might be a surprise to you. This is a monomial, okay? And here's why. You'll notice there's no plus or minus. This is really 4a squared times 3b squared, okay? So pronounced as 4a squared, 3b squared. It's considered one term because they're not separated. It's all of this is multiplied times each other, okay? Here are some binomials, and I can see right away I've got a term separated by plus or minus, so it's a binomial. Second one, here's a term separated by a plus or minus, all the way to this one at the bottom here. Again, it's all multiplied by each other, separated by plus or minus. Two terms, binomial, okay? And I'll come all the way here to the far right here and look at the bottom one. 7c to the fourth is one term. It's all multiplied by each other, separated by a minus sign. Here's another term, and here's a third term. So it is a trinomial, and each of those are examples of tri, okay? All right, I'm going to move on to the next slide. I do want you to copy this one down, so I'm going to pause my recording, hopefully. Yes. Okay, folks, hope you guys are doing okay. So I just wanted to kind of reinforce a couple of concepts, what we've just been talking about here. So in this number at the top of the screen, negative 5m squared n, okay? We already talked about that the letters are considered variables, okay? And they vary. To vary means to change, okay? Depending on what numbers would actually solve the equation, okay? So, and again, like we looked at it like this, 2x equals 10, okay? You know, 2 times 5, so in this case, x equals 5. But if I said 2x equals 12, we went through this last week, oh, x has got to equal 6, okay? So that's why they call them variables, because they change depending on what number would actually solve the equation. All right. All right. Another little piece of lingo is sometimes they call that number that's attached to a variable, they call it the coefficient. And if you're wondering, well, didn't we just call it a constant? We did, yes. But when it's attached to some variables like 5m squared n, then they sometimes refer to it as the coefficient, okay? And it's the number in that term. All right, speaking of terms, this is kind of an important concept. You might want to, in your notes here, underline this word like here, okay? Because the key concept is, how do you determine when terms are like, consider like, they're the same type of term, and unlike. And so let's look at 3 and -7 are considered like terms because they're both constants in a sense. Okay. I'm thinking about English consonants and vowels, but they're constants. Okay. So they're considered like terms. Okay. Now, this next example, if this was example 1 and this is example 2 here, -4c and 3c, they're considered like terms. And here's why. This is where I want you to really listen carefully, because they both have a coefficient and it's next to the same variable. Okay. So -4c, okay, you got a number and the variable c. In the next one, 3c, okay, it has the same variable. So this variable next to it, and it doesn't have any other, it's not, this one's not, 3c to the third or 3cd or something else. It just has 3c. These two terms, or c, it has c, and this is 3c. They're considered like terms. Now, why would that matter? Because we're next here tonight, we're going to add up like terms. We're going to have a list of terms in a row, and you got to figure out which ones are like. Okay, and we'll do it together. But that's the reason why this matters in algebra. Tonight's topic is simplifying algebraic terms. Okay, in example 3 here, I have 7x squared. Okay, so it's got x squared there. Okay, that variable here, x squared. And the next one, 4x squared, it has the same variable, x squared. Okay, so those two are like terms. Okay, and again, it matters because I could, if they were next to each other, if this was a plus sign between them, I could add them up and say that I have 7, 8, 9, 10. I have 11x squared, and I can do that because they are like terms. I can add together like terms. And likewise, example number 4 here, you've got 5v squared w and minus v squared w. Okay. Now, what's similar on this? Everything related to the variable here, v squared w, and I got a v squared w minus v squared w. So that's like minus 1 v squared w, okay, a v squared w. So think about it, if I was figuring it out mathematically, okay, those are like terms, that would equal 4 v squared w, okay, because I have 1 here and I have 5 there. So it's 1 from 5, it's 4, okay? Now let's look at some examples of some unlike terms, and that maybe will even help illustrate it even more here. A and B are unlike because they are different variables. You'll notice over here we had C on the left, C, same variables, they're like. But now we have different variables, so they're unlike, which means I can't combine them, okay, especially if they're together in if I was adding things, okay, adding things together. All right. So having said that, negative G and let's see here. I think I'm just going to shrink this, guys. Negative G and H are unlike terms because the variable is different. So we can't add those together, okay? Likewise, 3p squared and negative 2q squared. What's different? Well, they both have constants. 3 is a constant, 2 is a constant, and they both are squared, okay? But the variable is different. This p is different than q. They're not like terms, okay? So hopefully you're starting to kind of gather the idea, and we're going to review this on the next pages. C squared d and d squared c, those are not like terms because the c is squared here. Even though they both have a d and a c, only the c squared is c squared here, but it's the d squared here. So they're different. They're considered different, unlike terms. Okay. All right. So that's a little bit about like and unlike. And so this page, I don't want you to copy. I just want you to look at it. And we're going to kind of go through some things to kind of answer some questions together. This is review of what we just looked at. Okay. So answer the questions or identify the specific parts of the polynomial. And we learned poly means many and nomial terms. Okay. So if we've got this long polynomial, you'll notice it's not a monomial or a binomial or a trinomial. Okay. It's none of those, but how many terms does this polynomial have? All right, I want you to look at it for a couple seconds and see if you can figure out how many terms, remember things that are right next to each other, it has. Okay, if you're counting right, you counted 1, 2, 3, 4, 5, 6, and 7. So there are 7 terms here in this polynomial. Okay, again, separate terms are separated by plus or minus. Which term is a constant term? We just learned about what a constant is just a number, okay? Which term is a constant? Well, there's only one, and it's over here, okay? I'm gonna draw a box around it, -7, because it's -7, so it's like same as -7. It's constant, okay? List a pair of like terms. So now they want some like terms, okay? So let's look up here. I got 3y to the third minus 4y squared. Those are different because squared and third. Plus 13y plus 2 plus 2y squared. Okay, wait a second. Let me change colors here to illustrate this. Here's a number y squared here, and here's a number y squared here, okay? Those two are like terms. So you could say minus 4, boy, that's not a good color, is it? Let me pick this color. It's probably not much better. Green, minus 4 squared, 4y squared, and 2y squared. Now, you might be asking, hey teacher, how come you call the first one minus? Because in the equation, it's the same thing as a minus here, okay? Minus here, whereas 2y squared is positive because you're just adding it. By the way, there are some other like terms. If you're really thinking smart here right now, for some other like terms, this is a term and this is a like term. So I could have said 2 and -7. They are also like terms, okay? Because they're just numbers, they're just constants. Letter D, list another pair of like terms. Okay, well, we just did that, okay? So we're moving on. E, rewrite the polynomial in simplified form by combining like terms. All right, this is where we're kind of getting to a key concept of the night here, okay? So we're going to combine the like terms. I've got 7y to the third. Do I have anything else that's y to the third? No. So I'm going to write down 7y to the third, okay? Then I got minus 4y squared, and I got plus 2y squared. So that, if you combine these two, I'll draw an arrow from these two are like terms, okay? Combine them, it becomes minus 2y squared. Okay, you see what I did that? I got a minus 4 and a plus 2, so it becomes a minus 2y squared. Okay, then I got plus 13y And here's a 5y over here. So there's another one. So I'm going to do this. I'm going to combine them. I'm going to go 13y plus 5y is 5, 16, 16, 15, 16, 17, 18y. So plus 18y. Now I'm going to combine my other like terms, which is 2 and negative 7 would combine to be minus 5, because a negative 7 plus 2 becomes a minus 5. Okay, so that's a lot of what you're going to be doing in your homework this week, and your quiz at the end of the week, and in tonight's session for the next 10 or 15 minutes here, okay, or more, is combining these terms. Okay, hopefully that made sense. Let's do some more here. I'm going to skip this one here. It's the same idea here. So for the sake of time, all right. So here's kind of a new added concept to what we've been talking about so far. Adding polynomials. When adding polynomials, combine like terms. Well, that's what we just got through saying on the previous slide. Okay. So I'm going to go ahead and give you 30 seconds here to copy down what's on this slide, because I want you to. I was giving a presentation with another teacher once, and I was using the illustration of, yeah, earning credits, for your degree or your GED or your diploma, especially your diploma, is like putting things in a basket. You got all these kinds of fruit, and when you have all the right kind of fruit, you've got your diploma. And then this other teacher was saying, yeah, and so you got apples, you got pears, you got kumquats, you got peaches. And I started laughing. I said, wait a minute, kumquats? And so yeah. So she used a fruit that most people don't know about. But okay, so let's look at this example we have on the screen here. I've got 5x squared plus 4x minus 6. Okay, that's a kind of like looks like a polynomial all by itself. Plus 2x squared plus x plus 2. Okay, so we're adding. Sum means to add. Okay, we're adding these two polynomials. Okay, here's one, and here's the second one. We're adding these two. Okay, so if we combine like terms, I got 5x squared. That's x squared. This is x squared. So 5x squared, the next row here, 5x squared plus 2x squared. All we're doing is we're not even adding them yet. We're just sticking them together. So like it says, rearranging them so they're together. Plus 4x plus, here's the x that came over here. Okay, we put that there. Okay, so I'm keeping my like terms together, 4x and x. That's like 1x. Okay, those are like terms. Plus, and then minus 6. That's a constant. So there it is, plus 2. So all we've done here is, if I draw a box around this, is we've kind of combined our like terms in a sense, okay? And so I'm buying 3 different boxes here. Those are the 3 different sets of like terms. Now, we're going to go ahead and combine them. 5x squared plus 2x squared is 7x squared. So this becomes this right here, okay? This box here, if I really reinforce that is all one box right there, okay? Okay, that box there, 4x plus 1x is 5x. That becomes this. And my constants, my minus 6 plus 2 would be negative 4, so minus 4. That is combining like terms, simplifying algebraic terms, okay? All right, did I turn my recording on? I'm gonna just double check here. I hope I did. Really nervous to press this thing. I'm just moving on here. All right, this one here, I don't want you to worry about writing down. I just want you to think through it with me together, okay? So I've got 3b squared plus 6b plus 8. That's a polynomial, plus 5b squared minus 2b minus 5. Those are two polynomials, okay? And if we moved all of the like terms together, like by rearranging it, it would be 3b squared. Okay, here's this one right here, right there. And then here's the 5b squared. So we move this over here. 6b goes here. And this one over here has a b, so minus 2b. The reason we put a minus there is because this is a minus here, okay? And then we combined our constants, 8 and -5, plus 8, because there's a plus 8 here, plus 8 minus 5. Now I'm going to join them together. If I pick another color here, I've got these become this. These combined become this, 4b. And these like terms become this, 3. Okay? So that's an example of combining like terms and what they call simplifying. You'll hear that term in algebra a lot. Simplifying, it'll say, simplify this expression, okay? It means combine like terms, okay? All right, here's what I want you to do. Do we have time here for a few minutes? I want you to copy these 3 down, and I'm going to give you like 60 seconds to see if you can, on your own, simplify these expressions. Okay, they're all expressions because there's only something on one side of the equal sign. Okay, so go ahead and try to, sorry, I did it again. I will be right back, as they say. What did I do here? Oh, hang on there, folks. Yeah. Okay, come on. Did I really do that? Hang on, folks. Sorry. I am having sorry, guys. This is I will be right back. Okay, I'm having the cannot minimize Zoom when you are recording. Interesting. Huh, I just learned something. Okay, I'm gonna get it back. Sorry, guys. I guess it's what happens when you're trying to record and everything. So if you'll give me a second here. This is crazy though. I've never had this much trouble before. I will get it back though. Just a matter of, give me about 20 seconds here, okay? Yep. 70, copy of 70. I copied it week 10. I've got 2 copies of it. Interesting. All right. And get it back here. Okay, I'm almost there, guys. Sorry. I guess this is what they call having a little bit of a rough night in Zoom. How did class go? Well, I had a little bit of a rough Zoom night here. Now, if I can, here it comes. Where is it? There it is. Okay. Okay, guys, are we back? I hope I'm back. Yeah, I'm recording, sharing my screen, and this is where I was. So, all right. Yes, 9z plus 4 plus 3z plus 8. Okay, go ahead and copy those down and see if you can simplify those algebraic polynomials. Okay, they're also called expressions because they're like one side of an equation. I'll give you about 20 more seconds and then we'll jump into it. All right, I'm going to kind of go through number one here, guys. I've got 9z. That term is like this term. So those two combine, 9, 10, 11, 12. I got 12z. And then what's left are plus, okay? And I'm very careful to say plus there because I'm adding a +4 and a +8 plus 12, okay? That is simplifying that, okay? The next one, I've got 11m is a like term to 3m. 11, 12, 13, that's 14m. And then I'm looking at what I have left here. They're both positives, so it's +9, okay? Because these combine here, okay? In the next one, 11y plus 3y, okay? There's 2 there, but I'm just looking at the rest of the equation. There's a 5y over here, and it's a plus 5y. So I'm kind of going like this. 11, 12, 13, 14 plus 5 is 19y. And then I'm looking at what I have left. I've got +4 and a +3, so it's +7. Okay, I hope you guys did okay on that. Simplifying those expressions, okay? All right, just gonna kind of illustrate it now on this slide. For the sake of time, I think I'm just gonna go ahead and just show you how I do these. 7h plus 3h plus 4 plus 9, 70, that's 10h plus 9, 10, 11, 12, 13, okay? 2m squared plus 5m minus 4 minus 3m squared, okay? This is similar to this, which gives me a positive 3m squared. Then I got plus 5m, plus 5m, and then going over here, plus 3m. This is similar to this. These are like terms. So, and it's plus, they're both pluses here. I'm paying really close attention to that plus there. So it's plus 5, 6, 7, 8m, okay? And I've already used up, I did this one here. I used this one up here. I got rid of this one here, this one, what's left? I have a -4, and I'm paying attention to that minus sign, -4, -2. So -6, okay? That is simplified, the simplified version of that polynomial, okay? All right, now on this one here, we're doing the same thing, but there's just a little trick to it, I guess is probably the best word that I could use to say. Begin by replacing the two trinomials in parentheses, okay? So if they are, and I'll tell you what I want you to focus on. Here's one polynomial, and I'm subtracting this other polynomial from it, okay? Okay. So it's this thing minus this other thing, all right? So here's what we do. We begin by placing them in parentheses. So I took this first polynomial and I put it right here, okay? So you'll see how I have parentheses around 11y squared plus 3y minus 5. Okay, I put parentheses around that. Then I have minus, and I put the other polynomial in the parentheses. These little things here are called parentheses in English, okay? All right. Now, there's a reason why you do that, and it's kind of important in case you think, well, why are we going to go to all that trouble? It's already there, and why do I need to put parentheses around it, okay? Watch what you do here. So that basically what they did is take what I've got all right here, okay? And we just stuck the same thing down here. All right. Now, this is where it gets kind of interesting. This is where there's a little, we'll call it a trick here, okay? Or, you know, something to remember, okay? And it happens right here, okay? Here's the trick, okay? I want you to watch this. We didn't have to do anything to the first one, but since we're subtracting this one, okay, what they do is you take this minus and you put it right next to the 2y, but you're adding, you change this to an addition sign, an adding sign. So it's plus And then this is where it gets a little tricky. I got the minus 2y, okay? So that became this right here, became this right here, the minus 2y. But this is where it gets a little bit trickier. See that minus that's in front of the whole parentheses? That minus, and I got a minus over here. This is what I want you to pay real close attention to. A double minus becomes a plus. So that's why this, let me change colors here to make things a little bit clearer. This and this, okay, combined together, okay, became this right here, plus 7. Let me again say why. Because this minus is on the outside of the whole, with everything that's inside parentheses, the minus is minusing everything in parentheses here, okay? So now I can just combine like terms and get it all the way down to a simplified version of that problem. The key concept here, if I change color here and go with yellow here, key concept is remembering that when you're subtracting polynomials, you're going to put things in parentheses after that and then apply that minus to those numbers like we did here. Let's look at it again. Okay, let's do this again a couple times. Okay. All right, so this second example here, I got 5x squared plus 4x minus 5. This is a polynomial. It's in parentheses. Minus, okay, 2x squared minus 2x minus 3. All right, now what I'm going to do is I'm going to take this minus sign right here, and I'm going to change it to a plus sign right here. And I'm going to transfer the minus individually to every single term inside the parentheses. So it's plus, look what I did here. This is a positive right now, but now it's minus 2x squared. And then look what I got. I got a minus and a minus. See the double minus? So that's why it became a plus right here. Plus, and it's just minus 2x, so plus 2x. And then look what I'm doing again. I got a minus and a minus here for this here and this here, or minus and minus, so it becomes plus 3 here, okay? So I'm transferring the minus to every individual term inside the parentheses, and it will change things. Now, the reason you do that is so that it changes when you combine like terms. It changes, makes it easier to rearrange them together. Okay, so like 5x squared, okay, minus 2x squared, these are together, okay, plus 4x plus 2x. So we put just the number next to an x, put those together. In our constants, we put those together, minus 5 plus 3, those are together, okay? And then we can combine them even further. 5 minus 2 is 3, x squared. 4x plus 2x is 6x minus 2, because I have a negative 5, positive 3 becomes a minus 2. Okay, so that's the little trick there, is that when you're subtracting, and the key concept is when you're subtracting everything into parentheses here, you're going to individually apply it to each one, and then to this, which makes it a plus, and then to this, which makes that a plus, okay? Which now allows you to combine like terms properly. That's the little twist there, okay? So I want you to take 30 seconds and try one or two of these. See if you can do these on your own, applying what I just taught you. Okay, I'm going to, it says to simplify, that's where we're supposed to simplify each of the operations. I'm going to show you work. All right, so the first thing I would do is like this. I would go 10y minus 6. Then I would go plus, in parentheses, minus 3y, because I applied that minus to it. And I'm going to do minus 3. Now, if you're wondering, how did I get minus 3 here? Because I got the minus sign right here applied to this plus right here. If this was minus 3, then it would now be a plus 3 down here, okay? Now I can look at my terms. I got 10y minus 6 minus 3y. If I change colors to illustrate here, this term is like this term. These are like terms. They have a number and the letter y. So that gives me a positive 7y. And then negative 6 minus 3 would be minus 9. Okay. In my next example, all right, I could rewrite it and go minus 12a plus 3. And then I'm going to go plus because of this minus sign right here. And I'm going to apply the minus sign individually to each term within parentheses. So this becomes plus 3a because it's a double minus. And it's a double minus again, so it's plus 6. Okay. Then I'm going to combine my like terms. I'm going to look at and see, well, what's like each other? Minus 2a and plus 3a. Okay. Sorry, this is a little bit messy, but here. Okay. So this term is like this term. So I can combine them. Minus 12 plus 3, 12, 11, 10, 9. So I have negative 9a. And then I have a plus 3 and a plus 6, plus 9. Okay? Hopefully you guys are getting that. All right, I'm going to move on for the sake of time here. I'm running out of time. I think you got the general idea here. I think these are more examples, and I think you guys could kind of do that. I need to get to my last couple of concepts in 5 minutes. Again, it's the same idea here. This would be plus. And then, by the way, if you want to think about like terms here, 12x squared is similar to minus 2x squared, okay? But this would become a plus, but those are like terms, okay? 4x would be combined with just x right here. Those are like terms. And then this and this, those are like terms, okay? All right, last main concept for tonight here is greatest common factor, finding the greatest common factor, okay? And I think you guys, this at first slide here is kind of a review. I mean, the yellow is kind of a review of the greatest common factor of 12, 16, and 20 is the biggest number, or the biggest thing that multiplies consistently into each of the 3 numbers, okay? Well, 4 is the biggest number that goes into all 3 of those numbers. 4 is the greatest common factor because 4 goes into 12 and 4 goes into 16 and 4 goes into 20. There's nothing greater, okay, the GCF, greatest common factor, there's nothing greater that goes into all 3 of those, okay? So when we're looking at constants, these are all numbers, constants, that's how we find the greatest common factor. But how do we find the GCF, the greatest common factor, of something like this, 15xy, x squared y, and 18x to the third? Okay, a little bit of a trick to this. All right, they both have constants, okay? But what's the biggest number that goes into both 15 and 18? Can you think of what it is? It's 3. 3 times 6 is 18. So 3 becomes the greatest common factor of the what they call coefficients now, because they're stuck next to a variable, okay? Now, let's treat just x here, just this x squared here. All right, now this is where there's a little bit of a trick here, but I'm just looking at these two things here, okay? All right. The greatest number thing that goes into both of these, we would say, is x squared. And I'm going to tell you why, in case you're wondering. Because x squared has x squared in it, and x to the third has x, it would have x squared in it also. And so we would only keep the amount of it, because it's a factor of it, that they share in common. X squared and x squared here. So this would be x squared. And then we would just put down y, okay? So what we've done is found that's the greatest common factors of this, okay? We've basically, it almost looks like we're simplifying it, but I want to show you a couple more, okay? Because I want you to see that. I'm giving you a couple seconds to copy that in case you're frantically copying. Let's do a couple more. Okay. So look at this, and this will help illustrate this idea if we do a couple here. We've got x, y squared, and x, y to the third, okay? What is the greatest common factor? They both have x, and they both have y squared, okay? Because this has y squared, and this has y to the third, so that's as far as they have in common is squared, okay? So if you write those down in your notes there. Let me do the next one here. Number 12, got a to the fourth, b to the third, and then I got a to the second. You see these right here? Okay. So the greatest common factor between those two variables is a squared. Now, I've got b to the third and b to the sixth. The greatest common factor between that is b to the third, because here b to the third, and this is b to the sixth. So the greatest common factor is a squared b to the third. Okay. I know this is a bit of a stretch here. All right, last couple minutes here. Last minute, I guess. A to the number 13, a to the third, and b a and a c to the third. So what do we have? They both have a in common. Okay, that's all they have in common is a. Let's move on to the b. There's no b over here, so we could just say we could say just c squared, because that's what they have in common. They both have c. This one has c squared. This one has c to the third. And so I'll just keep the lowest of the two, because that's what they have in common. Okay. All right, I got to let you go. I've run out of time, but that's pretty much my last slide here. Okay. So those are the concepts. I hope that was helpful, guys. I did warn you that we're going to cover a lot of ground here tonight, and we covered a lot of ground. So I hope that was helpful.